There's something about watching a colossal machine at work that fills us with awe. But is there anything more satisfying than watching something of that scale complete an even more gargantuan task? Let's find out as we check out some of the world's most extreme engineering machines building amazing megastructures. Tunnel boring machines. Have you ever wondered how new subway tunnels or underground highways are dug through the middle of busy cities? This is a giant infrastructure undertaking that needs to be tackled from below, usually with the help of tunnel boring machines. A great example of this is the ongoing construction of Australia's Forestfield Airport link. It currently requires the use of 2 tunnel boring machines designed by German company Henrecht, costing approximately $20 million each. With their 39-foot radius rotating cutter wheels, these machines easily break material away from the tunnel's rock face. The gravel is then transferred to the belt conveyor system via a screw conveyor, whilst the hydraulic system continuously pushes the machine forward. Reinforced concrete segments are then installed, matching the tunnel's curvature. These form rings to reinforce the tunnel the machine bores, and once each ring is completed, the hydraulics are able to push against the new segment to propel it forwards. In Australia's Forestfield Airport Link project, around 9,000 rings are currently being placed along 5 miles of tunnels. It might not seem far, but in order to prevent major vibrations and disruptions, technology being used in this way needs to go very slow. Because of this, the 2 machines working on Australia's Airport Link project started in late 2017. And they're not expected to be finished until late 2020. Slow and steady may win the race, but at least it isn't boring. Tower cranes. Cranes are some of the most incredible pieces of mega machinery that many of us city dwellers see every day. And making the most of their machines in the best of ways, one of the world's leading crane companies, Liebherr, constantly put their engineers and machines to the test. This comes in many forms, from customer celebration days where they get big cranes to lift smaller cranes, to installations showcasing what their engineers can accomplish in their spare time. But their practical applications are where their cranes become truly impressive, especially when it comes to tower cranes. Construction site ground space is a precious commodity, so having multiple vehicles and lifting equipment can be more of a hassle than a help. Tower cranes remove that complication by hosting all lifting and moving activity in the free airspace above the site, freeing up ground room. Depending on the series, Liebherr's largest cranes can reach as tall as 1,500 feet for specialized constructions of exceptionally tall buildings, like St. Petersburg's Lochta Tower. While most tower cranes aren't quite so tall, the shorter ones are no less impressive, with some able to lift loads approaching 42 tons. All of this is made possible by incredibly resilient, thick steel lifting cables with thinner strands around a larger central core to distribute the weight. The modular design of tower cranes means they can be easily erected by other smaller cranes and can also be disassembled in a similar way. For ease of construction, however, the central pillars of tower cranes are often built into the megastructures they create. Some tower cranes can even climb while inside a building, reaching higher as construction progresses. This central positioning allows for fast construction of megastructures like China's T30 Hotel, a 30-story skyscraper with 330 guest rooms built back in 2012. With the tower crane at its center, construction of this colossal building was completed in just 15 days. That's one high-speed high-rise. Georgia Power Nuclear Plant. Tower cranes may be the undisputed king of skyscraper construction, but when you need to move something heavier a little further than they can reach, being static becomes a problem. Construction plots like the nuclear plant Vogtle in Georgia can span over 3,200 acres, which is almost large enough to house Central Park 4 times over. In large plots like these, crawler cranes are the weapon of choice for several reasons. For starters, Units 3 and 4 of Georgia's Vogtle expansion project had nuclear containment roofs weighing in at over 900 tons apiece. Being 135 feet in diameter and 37 feet tall, each of these rings weighed more than 2 jumbo jets. With even the heaviest load tower cranes typically topping out around 50 tons, they needed something with a little more power. So they went with the Lamson LTL 2600, a fully mobile crane with a 400-foot boom that can lift up to 1,200 tons, making it perfect for this heavyweight job. Now that's what you call a powerful reach. Asta Hanstein Rig Spar. Have you ever wondered how an oil rig is constructed so far out at sea? These are some of the biggest nautical structures in the world, and the colossal machines that help build them are just as impressive. Take for example the world's largest oil rig, the Aasta Hansteen. The spar platform of this incredible structure was built in South Korea and measured in at 656 feet long, 164 feet in diameter, and over 46,000 tons in weight. This incredible megastructure needed to be transported all the way from Korea to the coast of Norway, which is where the global market leader of heavy marine transport stepped in. This is the Boskalis Dockwise Vanguard, a semi-submersible heavy transport vessel which can sink over 90 feet beneath the waves, allowing heavy machinery to float onto the platform instead of being laboriously lifted. The latest versions of these bowless design vessels accommodate an astonishing deadweight capacity of over 117,000 tons. The journey took just over 2 months, traveling 14,500 nautical miles. When it arrived at its designated site in December 2018, 50 million liters of water were pumped in to raise the hull, and it slowly ascended like an oceanic colossus. Teen Ung Project. So you've seen what goes into constructing the underground portion of an oil rig, but where do oil field workers live and store equipment while at sea? The answer is up top. But as we saw with the Aasta Hansteen spar platform, nothing of this scale is ever built from scratch in the middle of the ocean. The top of the Teen Ung BKTNG field rig was no exception to this rule. Built offshore, the project required a 4,200-ton topside and an 850-ton living quarter on top of that. Now, lifting things on land is reasonably straightforward, as most machines can be grounded and counterweighted on the earth. Marine lifting vessels, though, require complex engineering to ensure that the entire operation doesn't capsize. For an undertaking like the Teen Ung rig, which was at the time the world's heaviest nautical lift installation, they needed to bring in the big guns. And boy did they. This great beast is the fantastically named Asian Hercules III, an offshore heavy lift shear leg crane. This self-propelled floating machine reaches a height of almost 350 feet and can carry out lifts exceeding 5,000 tons. You may be wondering how something lifting such heavy loads in the middle of the ocean stays upright without capsizing. The secret lies in the ballast tanks that skirt the edges of its base. Each is filled with precisely calculated amounts of seawater to add stability and act as additional counterweight to the objects lifted by the crane. The large wide base platform's natural buoyancy takes care of the rest. As you can see, it all worked amazingly well, and the Asian Hercules III made impressively light work of this gigantic installation. Wickinger Wind Farm Installation. If you've flown on a plane in the past few years, you may have spotted one of these offshore wind farms in the sea. But have you ever considered how big these renewable energy generating wind turbines are up close? While onshore, wind turbines can reach 575 feet in height. Offshore turbines can hit a gargantuan 853 feet. For perspective, that's over half the height of the Empire State Building. Much like other offshore projects, these colossal structures need a host of mega machines to move them into place. The Wickinger offshore wind farm installation was undertaken in 2017, placing over 70 turbines off the coast of Germany, and they used the Fred Olsen wind carrier to complete the most fundamental stages of the job. This uber machine is a jack-up vessel, which is a ship that contains 4 self-elevating ballasts that settle on the ocean floor and hoist the ship above the waves. This means construction of the giant structures isn't limited to the height of the ship's attached crane and allows the offshore operators a greater degree of precision during building. The crane itself can support a maximum weight of almost 800 tons and slots the individual turbine pieces together like a kid assembling a Lego set. That'll put some wind in your sails. Wiggins Island Tandem Cranes. While we'll hopefully someday reach a world solely powered by renewable energy, we're currently still relying on fossil fuels like coal, gas, and oil. So the creation of gigantic new coal export terminals is still a priority, and these terminals continue to be among our greatest engineering feats. Take the Wiggins Island Coal Export Terminal, for example, which was designed to export over 120 million tons of coal from Australia's east coast every year. To achieve this, they needed infrastructure on a mammoth scale. Coal stacking bridges are an essential component, and to build this 1.1-mile 2-mile jetty, mobile cranes with rotational flexibility were essential. This called for 2 Lamson LTL 2600 Transi-lift cranes working in tandem to lift these enormous structures into place, and they did it with seriously impressive maneuverability. Then it was a matter of welding everything in place with the help of an army of cherry picker lifts. It's like they say, teamwork makes the dream work. Cofferdams. Ever wondered how the legs of bridges get built right in the middle of a body of water? It's a fascinating process and involves 2 little things, or rather enormous things, called sheet piling and cofferdams. Sheet piling involves the interlocking and overlocking of huge steel beams, which is a method most commonly used in constructing these enormous metal cylinders, formerly known as cofferdams. These steel enclosures are dropped into riverbeds and seabeds, after which the water is pumped out, creating a dry environment for workers to undertake tasks like bridge foundation building. In some cases, like this project from Great Yarmouth in the UK, enormous shear leg crane barges are employed to lift each of the giant steel cells out into the water. The particular cells used in Great Yarmouth, each weighing in excess of 400 tons, were lifted from the quayside and floated into position. But in some cases, the shape, weight, and height of the structure make it difficult for this kind of exact positioning. In these cases, the cofferdams are launched straight down a slope right into position, like the 800-ton Wuxi Yangtze River Bridge cofferdams. Once in the water, they can then be gently floated into location, fixed to the riverbed, and drained, so the next stage of construction can begin. Cofferdam, that's impressive. Which of these machines and their mega structures impressed you the most? Let me know in the comments below, and thanks for watching.